I think I have time for one more. We finished week 4. Huzzah. Right, and then week 3 I already checked to see they still don't have a Rust version for that. So now we're search in a rotated array. Grind 75, week 5, problem 33, search in rotated sorted array. Okay? There's an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, such that the resulting array is nums k plus 1, nums n minus 1, nums 0, 0 indexed. Okay, I get this part. Given an array nums after possible rotation and an integer target, return the index of target if it's in nums or -1 if it's not in nums. So can't we just search? Oh, you must write an algorithm of log n runtime complexity. All right, so they're saying use a binary search, use a binary chop algorithm instead of just doing a linear search through the vector. Which is interesting, right? Because binary search typically work on a fully sorted array, but now we have 2 sub-sorted arrays. I guess one thing we could do is find out where this point is and then do a binary search within either the lower half or the upper half. Right? I mean, that's one approach. So let's copy this. And another approach is what? I don't know. Is there any other way to do it? I guess that's the most obvious way to do it, right? This is number 33, right? Lib 0033. Oh, okay. I was going to try to avoid scrolling up, but there you go. Search in rotated sorted array. There we go. Create the file. Go there. Pub. Struct solution. Paste. Oops. Paste. 0. Okay. Julian says if you look for K first. Well, you can look for, you can find this point using O of log n, right? Because you could binary search for this, and then you just binary search for the remainder of the thing, and that whole thing would be just O of log n. Because 2 sequential O of log n searches is O of 2 log n, and we all know we throw away the constants. 2 of O of log n searches in a row is still an O of log n runtime complexity. So, I mean, that might be the approach we take. It seems like the most straightforward to do it. So let's give it a shot. Test mod, test, ex1. We're expecting the answer 4, and we're going to give it solution search, effect bang, oops, effect bang, 4, 5, 6, 7, 0, 1, 2. And then the second example is -1 expected answer, solution, search. Oh, I got to give it what we're searching for, right? The target, comma, 0. Search, vec bang, 4, 5, 6, 7, 0, 1, 2, and we're looking for 3, which doesn't exist. And then our final, ex3, -1, solution, search, vec bang of 1, target 0. Okay. And I misspelled this. S-E-A-R-C-H. There we go. So these should fail. Vasan Mar says typo on solution. Oh, thank you. Yeah, there was the underline, but I was ignoring it because underlines are easy to ignore. All right, so this is good. Let's swip over to the test page, and it should show us that we're failing all of these tests. Joel Wayne says, isn't there a problem that you don't know in which direction k is if you start in the center? Right, so you wouldn't actually start in the center. What you do is do a binary search for two numbers where the second number is lower than the first number. Let's take a look at the constraints. Right, so this is what I was looking for. All values of nums are unique. So we're never going to get duplicate nums, which means that there's going to be a point in the array somewhere. Well, first of all, we can look to see if the first and last, right? If the first number is less than the last number, then we know that the array is not rotated. Otherwise, we can look for a point in the array, right? And if it's not rotated, we can just do a regular binary search. Otherwise, there's going to be a point in the array where number n is greater than number n plus 1. And in that case, that's where this thing splits, and then we can just do a binary search either on the lower half or the upper half, depending on what our target number is. Does that make sense? So we got to find this quote-unquote pivot point. And once we find the pivot point, then we can do a sub-binary search. So how do we find the pivot point? Well, let's just use our normal let mut start equals 0. Let mut end is equal to nums len minus 1. Right. This is the standard way we start off a binary chop. While start is less than end, we pick a midpoint. Let mid is equal to start plus end divided by 2. All right, so now right, if nums of mid is greater than nums of end, right? If this is greater than this, then we're finding a point on the pivot. We're getting closer. The mid is closer to the pivot. So we're going to say start is equal to mid plus 1. Otherwise, it's not, and we're going to pull in the end. So n is equal to mid. And that should give us our pivot point. Let's find out if that's true. Print lin. And it'll be, because of this, it'll be whatever start is. Start is equal to start. Let's see if this gives us what we're looking for. Oh, and I got to remember that we got to return something. Stupid Rust making me actually make my program compile. All right, so here's start is 0, here's start is 4, and here's start is 4. So are we right? 0, 1, 2, 1, 2, 3, 4. Yeah, so for both of these cases, it's finding the pivot point just by doing a binary search, right? So basically, we're just looking for the point where these go the opposite direction, because these are monotonically increasing until we hit the pivot point, at which point it starts again monotonically increasing, but from a number less than that. Okay, I think we're good. This one says 0 for the pivot point, which makes sense because there's only one entry in it. And now we can either say, now we have to pick out which range we actually want to use. Whether we're picking out the left half of the array or the right half of the array. And we can just look at that, right? Using the target, if target is greater than or equal to nums of start. And target is less than or equal to nums of end. So if it's in that range, then start, yeah, then start is where we want it to be, and then we'll just say the end is equal to nums len minus 1. Else, It's hard to do this in my head. End is equal to start, and then start is equal to 0. Does that work? I don't know if that's going to work. We might have to do it in 2 steps. Okay, so let's do that now. I'm going to say search in range start to end. All right, let's see what this says. Search in range 4 to 6, search in range 0 to Oh, that's right. Yeah, because this should not find it. That's fine. And then search in range 0 to 0. Okay, so I think we're good. Let's try this now. And all we need to do is return, what are we returning? The index of the, return the index of the target if it is in nums, or -1 if it's not in nums. Okay, so now we just do another binary search. While start plus end mid is equal to start plus 1, end over 2. If nums mid is equal to target, then we found it, return mid. Otherwise, if nums mid is less than or equal to target, it shouldn't be equal, right? I shouldn't have to say that. Maybe I'm being paranoid. Start is equal to mid plus 1, else if, else, that's it, yeah, end is equal to mid minus 1. Right? That's all we have to do, and then -1 if we didn't find it. What could possibly go wrong? Well, the first thing is we have to make as I32, and then it panicked. Subtract with overflow. Oh, and that's on line 33. Yeah, right here. Okay. That means mid is 0. If mid is 0 and we haven't found it, then we haven't found it. So we have to put a little extra case in here. If mid is equal to 0, return -1. All right, well, that passes the tests. It's kind of sloppy. Let's see if it actually passes our Leetcode. Paste. Wrong answer. Oh boy. So nums 1, 3, the target is, oh, what is this? Target is 3, and I outputted -1. Okay. So, yeah, I didn't actually test, other than this can't find it, I didn't test a sorted array. So let's add this as our fail 1. We were expecting 1. And solution search vec bang 1, 3. Is that it? 1, 3, target is 3, and the output should be 1. Yeah. So that failed. Jules says, I think if K is in your left half, your K search breaks. Okay. All right, so we're able to reproduce the test failure. Yeah, we might have to do this in 2 steps. Let's copy the pivot point. And then what we can do is we can just set start to 0, and then end is equal to nums len -1. And then here we just update the start to our pivot point. And then here we just set end to the pivot point. Right. That way we do this hopefully properly. Oh. And now it causes this one to fail. Example 1. Yeah. I wonder if this, I was being paranoid, but nums mid should never equal target, right? Because if it does equal target, yeah, I didn't need to do that. Oh, yeah, I'm sorry. I should have set this to the pivot point. There we go. Okay, so now it works. So yeah, we had to do this in 2 stages. Basically set the range to the full range and then either move the start up to the pivot point or move the end down to the pivot point. Yeah, I didn't see that when I was doing it the first time. So, all right. So hopefully this will work. Let's grab all of the lines so I can just say select all, paste, and submit. There we go, accepted. Not fast. Memory's good. Oh no, sorry. I keep getting these backwards. Why? So it is pretty fast, but uses more memory than a faster solution. So let's take a look at the low bound here. Mid equals left plus right minus left over 2. What? Isn't this the equivalent of left plus right divided by 2? I think if you work that out, because it's left over 1 plus right minus left over 2. So it's left, 2 times left, plus right minus left all over 2. Yeah, and then you say 2 left minus 1 left is 1 left. So yeah, this is just left plus right over 2. Okay. Somebody's getting a little over fancy here. If we found it, then return it. Oh, okay. So they don't look for the pivot point and then find it. They actually just change the way they update this. If nums left is less than target and nums target is less than nums mid. So if it's between left and mid, then we update left and right this way, which I call start and end. So right is end and left is start, right? And then if target, they should have stuck with this consistency here. Target is greater than mid, target is less than right. So it's between mid and right, mid and end. Then we'll update start. Otherwise, we'll update end. Okay. That seems cleaner. And it looks like they had an alternate solution here that didn't quite work. Or maybe it was too verbose for them. Anyway, this is good. It doesn't use as much memory for some reason, even though this doesn't really use that much memory. It just goes through 2 steps instead of 1 step. So I like this solution better. And then a runtime. Yeah, so here's another person who did it in 1. So if it's between target is less than nums of 0 is equal to nums of mid is less than nums of 0. So if these Boolean expressions resolve to the same, both false or both true, that's an interesting technique. And here's another low plus high minus low over 2. Is this something that like gets taught in school or something and then people just blindly accept it? Because it's the same thing as this equation here. It probably assembles to the same thing if LLVM is smart enough. What's the name of that Rust compiler explorer? Now I'm curious. Godbolt? No, Rom says Godbolt too. Okay, good. So now I'm just curious. So I'm going to say A plus B over 2. And what does this compile to? Oh, yeah, it's got checking. We got to turn on. How do I turn on release mode? Where's release mode in this thing? Add tool. Filter. Output. Execute the code. Wow. That's compiler options release. Can I do that? Compilation failed. Unrecognized option release. Oh, how do I put a release mode if I can't put -- release on here? Yeah, it's putting release in there. Oh, do I have to put like 03 or something? No? Maybe I just put O. There. Okay. Yeah, so it just that's interesting. It adds them and then shifts right by 31. What? Okay, and then the other solution was A plus A minus B over 2. Yeah, it compiles to the same code. Right? At least I think it does. Now I've forgotten what the other one looked like. All right, here we go. And this is the copy this, paste this, and then the other way here. Oh no, this is better. This is shorter. Oh, I forgot to hit copy. So we can compare them here. Yeah, so these are the two versions. Interesting. Kafka says -C opt level. -O is O2 in GCC. Okay, well let's try that. This -C opt level equals, I assume it goes up based on, oops, got to type level correctly. All right, and then, right, that one always does the right thing. And then this is was it low minus high? I forget now. High minus low. Low plus high minus low. I guess it doesn't matter because it all works out to be the same thing, right? A minus B. No, let's do it the other way around. B minus A, because I think that matches the code more directly. All right, so let's take a look at these two together. Yeah, so this is the average version, and this is the, yeah, it's a little longer, isn't it?